Hello everybody and welcome back to a brand new video, and in this video I will be covering problem C, that was monoblock from round 816, right? So let's get started. So in the problem we have been given an array of size n, right? So something like a1, a2, a3, so on up to an. We have also been defined a thing called awesomeness, something called awesomeness of an array, right? So if you want to find awesomeness of an array, it is just the minimum number of contiguous blocks, minimum number of identical contiguous blocks we can divide the array into. Array can be divided into. For example, if you have an array something like 1, 2, 2, 2, 3, 4, 4, 4, 5, 5, then the awesomeness of the following array will be how much? Awesomeness of the following array will be, we have one block, we have the second block, the third block, the fourth block, and the fifth block, right? So the minimum number of contiguous blocks that you can divide this array into is 5, right? So that will be the awesomeness of this. If we call this array, let's say array B, then the awesomeness of array B will be how much? Awesomeness is equal to 5, right? So that is the awesomeness of the array. So that is the first term, that is awesomeness. And the second thing is the answer. Answer is nothing but sum of awesomeness over all the subarrays of some array A, right? For example, if you have an array something like 1, 2, 2, 3, 4, 5, right? Let's say this is your array A. Then if you want to find the answer for the following array A, it is the sum of awesomeness over all subarrays, right? So the subarrays you can have here is, you can have 1, 1, 2, 1, 2, 2, 1, 2, 3, 4, 1, 2, 3, sorry, 1, 2, 2 here, 1, 2, 2, 3, 4, 5, right? Or you can also have 2, 2, 3, 2, 3, 4, right? So you have to think about all these subarrays and you have to find awesomeness of each subarray, and your answer will be the sum of awesomeness of all the subarrays of A, right? So these are the two terms. I hope you're clear with the terms, right? So we have two terms. One is awesomeness, that is the minimum number of contiguous blocks that you can divide an array into, and the second term is your answer term. Your answer is just sum of awesomeness over all the subarrays, right? So these are the two terms. So you have been given an array of size n, right? A1, A2, A3, so on up to an, right? Along with this, you have been given q queries, right? In each query q, you can choose some index I and set and take some element x and set a of I equal to x, right? So in each query you have been given two things. One is the index I and second is the element x that you want to change it to. So for given I and x, you can set a of I equal to x, right, for each query. And after each query, you have to find the answer for your array A. Right? So that is the problem. So given an array of size n and given q queries, you, after applying each query, you have to find the answer for it, right? So that is the problem. So how can we approach this? So to approach this, so let's start with the observations. So to solve this, first of all, let's see how we can think about awesomeness, right? So we know awesomeness of array is equal to number of contiguous blocks, right? For example, if you have 1, 2, 2, 2, 3, 3, 4, 5, 5, the awesomeness of the array will be how much? We have 1 block, we have 2 block, we have 3 block, we have 4 block, and we have 5 blocks, right? So the awesomeness of the array is equal to 5, right? So currently we are thinking awesomeness in terms of contiguous blocks, right? So if we try to think about in number of contiguous blocks, it will not help us in the answer, right? So instead of thinking about this as number of contiguous blocks, we can think about this as number of barricades between distinct elements plus 1, right? So we have now redefined the awesomeness. Instead of thinking about awesomeness as a number of contiguous blocks, we are thinking of awesomeness as number of barricades between different elements plus 1 extra, right? For example, we have 1 and a 2 here, so there should be a barricade here, right? We have a 2 and a 3 here, so there should be a barricade here. We have a 3 and a 4 here, so there should be a barricade here. And we have a 4 and a 5 here, so there should be a barricade here. So we have in total four barricades and plus 1 extra we are adding, right? So we will have 4 barricades. We have 4 barricades plus 1 extra, right? So our awesomeness is again 5, right? So you can see our awesomeness is not affected. Our awesomeness is same in both the cases. If you count number of contiguous blocks, or either you count number of barricades and add 1 extra, right? So now we have redefined our awesomeness. Our awesomeness is equal to number of barricades between different elements plus 1 extra, right? So that is now definition of awesomeness, right? So now let's see how we can think about answer, right? So let's see how we can think about our answer. So we have our answer. Our answer is just sum of awesomeness over all subarrays, right? Sum of awesomeness over all subarrays, right? And as you can see, our barricades are contributing to our awesomeness, right? Our barricades are contributing to our awesomeness, and our awesomeness is contributing to our answer. So if we can find the contribution, of barricade directly to answer, that will be really helpful, right? So you don't want to find the awesomeness for every subarray. You can just find the contribution of each barricade that it is contributing to our answer, right? So how can we find that? So let's take some example. So let's say you have 1, 2, 2, 3, 4 and 5, right? So we have barricade here, we have a barricade here, we have a barricade here, and we have a barricade here, right? And we know our awesomeness is how much? Our awesomeness is directly proportional to number of barricades, right? And our answer is how much? Our answer is sum of awesomeness over all subarrays. This should be sum of awesomeness over all subarrays. So how can we find the contribution of this barricade over all the subarrays, right? So we can just count the number of subarrays that will contain this barricade. So how many subarrays will contain this barricade, right? So if you see, we have 5 elements on the right side and we have 1 element on the left side. So in total 1 into 5 subarrays, 1 into 5 subarrays will contain our following barricade, right? So 1 into 5 is how much? 5. So 5 subarrays will contain this barricade, right? So the following barricade will contribute how much to our answer? The following barricade will contribute 5 to our answer. It will be in 5 subarrays, so it will contribute 5. This is my barricade 1. And how much will the second barricade contribute? We have 3 elements. We have 3 elements on the left side and we have 3 elements on the right side, right? So it will be how much? It will be 3 into 3, that is 9 subarrays. So the following barricade will belong to 9 subarrays. So it will contribute 9 to our answer. So it will contribute 9. Similarly, if you think about the third barricade, right? It has 4 elements on the left side and it has 2 elements on the right side. So it will contribute how much? It will contribute 4 plus 2, 8. This is my barricade 3. And what about barricade 4? It has 5 elements on the left side and 1 element on the right side. So it will contribute how much? It will contribute just 5, right? So these were the contribution due to the barricade. But if you see our formula for awesomeness is number of barricades between different elements, right? So it has some contribution from the barricades, but there is also plus 1 extra, right? So all the subarrays will contribute 1 extra. So you also have to find the contribution. You also have to find the contribution due to 1 extra, right? So you can write contribution due to extra ones, right? So every subarray will contribute 1 extra. So you can just say contribution due to extra ones will be how much? It will just be equal to number of subarrays. Number of subarrays. And number of subarrays is how much? It is just equal to n into n plus 1 by 2, right? So we have how many elements here? We have 6 elements here. So it will be how much? It will be 6 into 7 by 2. So it will be equal to 21, right? So our answer will be how much? Our answer will be 5 plus 9 plus 8 plus 5, right? These were due to the barricades, and plus how much? Due to the extra ones, it will be plus 21, right? So you can just find the answer. It will be 17, 27. So it will be 48, right? I think. So our answer is just 48, right? So you just found the contribution of the barricades, and you were easily able to find the answer, right? So if you know the position of the barricades, you can find the answer in O of n, right? So if you know the position of all the barricades, we can find the answer in O of n, right? But the question still stands. We cannot do this for every query, right? Because if you try to do this for every query, it will take you O of n into q time, right? And both n and q are of order 10 to the power 5, and it will TLE, right? So we cannot do this for every query, right? So we have to find something to find the answer for every query in constant time. So how can we do that, right? So let's see that. So now we know how to find answer. Because we redefined our awesomeness, and using that we were able to find our answer. So now we have to do something about the queries, right? So if you see the queries, we have 1, 2, 2, 3, 4, 5, right? The previous example. So if you see the barricades, we have a barricade here, 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 right? So in the queries, you are just taking some element, and replacing it. For example, if we take a 2 and replace it with, let's say, 3, right? So if you think about it, we are replacing some element, and the barricades on its left side and right side will not be affected, right? So if you replace your third element, right, elements that are on the left side, the barricades that are on the left side, right, from index 2 won't be affected, right? These barricades won't be affected. Similarly, barricades on the right side, these won't be affected as well. These won't be affected as well. Only the barricades that are adjacent, right? So if I am changing my element 3, the barricades that are adjacent, so the falling barricade, only the falling barricade will get affected, right? So the falling barricade will be removed, and a new barricade will be inserted on the left side, right? So when you change an element, only the barricades adjacent to that element will be changed, right? So that is our observation, right? So only barricades adjacent to the current position will be affected, right? So if you see here, our answer was previously how much? Our answer was previously 48. And now when you change the element, the falling barricade was removed, right? So how much was this contributing to our answer? It was contributing 3 into 3, right? It was contributing 9 to our answer. So we can remove 9 from our answer. So my new answer will be how much? 48 minus 9. That is how much? That is 39, right? But if you see, now a new barricade has been inserted in the falling place, right? So we have 4 elements on the right side and 2 elements on the left side. So that is contributing how much? That will contribute 4 into 2, 8, right? So we have to add a new 8 to our answer. So our answer will be how much? Our answer will be equal to 39 plus 8, that is 47. So my new answer is equal to how much? 47, right? So now for every query, first of all, for the very first time we can find the answer in O of n. Then for every query, we don't need to find the position of all the barricades, right? Because only two barricades will be affected at most, right? The adjacent barricades. So we can just iterate over the nearby barricades, right? And find the answer. So that will be how much? That will be O of 3, or that will be just O of 2 into Q, right? Instead of n into Q, we just need to think about the two adjacent barricades. So our complexity will be O of 2 into Q, right? So in total our complexity will be how much? It will be O of n plus 2Q, right? So that will be our total time complexity, and it is obviously doable in O of n, right? So that is the solution to the problem, right? That is how we will solve the problem. So I will summarize the solution once again. We'll summarize the solution. So the summary is, you can redefine awesomeness as number of barricades plus 1, right? And then you can find your answer just using position of barricades, right? Position of barricades. Each barricade contributes how much? Barricade contributes number of subarrays it belongs to. Number of subarrays it belongs to. Plus extra is how much? The number of subarrays. Extra is number of subarrays, that is due to the plus ones, right? Due to the plus ones. So now we found our awesomeness, we found our answer. And then for every query, we found the observation that for every query, only adjacent barricades are affected. Only adjacent barricades are affected. So just recalculate their answer. So just recalculate their answer. And that will be the solution, right? So we can take an example from the from the problem and show you how it works. So let's say we have 1, 2, 3, 4, 5, and the second query, that is 3, 2. Right? So we have the example as 1, 2, 3, 4, and 5. Right? So we have again 4 barricades. The first barricade will contribute how much? It will contribute 4 into 1, 1 into 4, that is 4. It will contribute 2 into 3, so that is 6. Again this is 3 into 2, again it is 6. Again it is 4 into 1, so it is again 4, right? So it is how much? 16, 20, right? 20 plus the extra due to the number of subarrays, right? So it will be how much? It will be 15, right? And into n plus 1 by 2, so that is 5 into 6 by 2, right? So that is 15. So we have answer is equal to 35, that is before any queries, right? So now we do a query and change this 3 equal to 2, right? So now the following barricade will be removed, right? So my answer 4 will still remain 4, right? The following 6, right? We remove the barricade, so 6 will be removed, right? Then we again have a 6, we again have a 4, again the plus 15. So it is how much? It is 10 plus 19, so it is 29, right? So if you see the answer, it is 29, right? So as you can see, only the barricades adjacent were affected, right? So that is how you can find the solution. So if you guys want to see the code for this, here's the code. So I have my number of elements and the number of queries. I take them as input. Then initially my answer is how much? It is the contribution of extra ones, so that is the number of subarrays, so n into n plus 1 by 2. Then I will iterate over my array, and if I find a barricade, that is if my v of I is not equal to v of I minus 1, I will add the contribution to my answer, so that is I into n minus I. That is the following thing, right? So that is how I find subarrays, so that is I into n minus I, right? That is how you can find the contribution of a barricade. So I find my initial answer, and then I started iterating over the queries, right? So for every query I take in I and my element x, right? So first I will check the barricades, right? So I will first remove the contribution of the adjacent barricades, right? Then I will change my element equal to x, and then I will find the new barricades and add their contribution, right? So first of all, remove the contribution of the barricades, then change your element, and then if there are any new barricades that are formed, add their contribution to the answer, right? So in the end, I can just print out my answer. So the contribution here is similar to the previous thing, because the contribution to the barricade is again I into n minus I, or I plus 1 into n minus I plus 1, depending on the position of the barricade on the left side or on the right side, right? So that is just simple mathematics. I hope you can do that on your own, right? So yeah, that was the basic solution. And if you guys have a doubt, feel free to ask me in the comments or join my Discord server, and I'll be more than happy to answer your doubts there. Yeah, so that is it for this video, and I will see you guys in the next one. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. So you can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long, and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below, and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.